My name is Varun Dutt, and this is the second lecture on Large Applications Practicum, where we are looking at JUnit or unit testing or software testing. So let's get started. So the basic testing architecture includes that you have Java code. You will perform unit testing using tools like JUnit, and then also you can use coverage tools, which we will look at, like ECLMA, and mutation testing tools. They will mutate the code and test the code and see how it performs. So basically we are going to look at all these frameworks. In this lecture, the focus will be on looking at how we can create unit test cases to test certain functions in the code and then go from there towards code coverage and mutation testing. So JUnit is a simple framework for writing and running automated tests for Java. It has been extremely important in development of test-driven development. JUnit uses annotations and methods to write test cases, and typically these test methods are contained in a class which is only used for testing. This is also called the test class. So typically we are going to use an editor called Eclipse, which I have already shown you how to install and deploy in the last lecture. If you have not seen it, please go and see it. And it's a popular Java IDK IDE, which is Integrated Development Environment, basically a Java editor, which allows you to use JUnit as an integral component inside Eclipse. Eclipse support creation of JUnit via wizards as well. So now you can see that suppose we are already written some Java code within Eclipse, which is like multiply class.java, and here we have created a JUnit test case called test multiply.java, which is another Java file. And then in this particular case, see, we have written, this is the multiply class, which is nothing but multiplying two numbers, and it's basically calling the multiply class and then printing out the multiplication of 2 and 3, which will be 6. And here you can actually see a 6.0, and here you can see that we can write a test case called multiply.java, which is where we can actually call the multiply function and test it out for different cases of x and y. So before we can do that, we need to install JUnit. Again, in my prior lecture, I had shown you how to install JUnit. And in general, we need to go into the project properties, choose Java build path, add libraries, add external jars to the library tab, and then select the JUnit package and click OK to install JUnit. So here we are basically adding to the multiply class a test case, which is basically called test multiply.java, which is also added in the package in Explorer within the same package, like test multiply.java, in addition to the multiply class.java, which is another file. So this is the second file which is added, and here we are going to write code in this file to run the test case. So here we will first define import the JUnit framework. Here note that JUnit has transformed from JUnit 3, 4 to 5, and this code is using JUnit 4. If you're using JUnit 5, you may need to write something different using API here. So import JUnit framework, we are importing the JUnit framework, then we are creating a class called test multiply, which extends test case, and then within this class we are using test multiply function, which is with an annotation called add test, and within that we are writing test multiply, which is kind of a constructor function where we are defining object of the multiply class, and then we are writing something called asserts equal 10 into 3 must be 30, which is command. This is the expected output, and this is the function call. Similarly, we write another asserts equal with the command expected output and the function call multiply. So if the function returns this value or this value, then the assert equals will be true and the test case will succeed. If it does not return this and this value, which is the expected output, the test case will fail and asserts equal will be false. So we want all our test cases to succeed. So as you can see, we have run this test case, and this green bar shows that both test cases succeeded, and we got the output which was equal to the expected output. So now we in this code use this @test annotation, which is a JUnit annotation, but we can use other types of annotations as well. So for example, @test public void method is basically annotation which identifies a method as a test method or a test case. @test expected exception dot class fails if the method does not throw the named exception. So there is a particular exception you can mention, and if it does not throw that exception, this will fail. And test timeout 100 fails if the method takes longer than 100 milliseconds, which can be used for checking non-functional requirements and functional requirements. Before public void method is executed before each test, it is used to prepare the test environment, read the input data, initialize the class. So this is like a method which will execute before the test case, before each test case to set up the test case. And after this method is executed after each test case, and is used to clean up the test environment, delete temporary files, also used to save memory by cleaning up extensive memory structures, like for example destroying object. And before class, this method is executed once before the start of all test cases or tests. This is used to perform the types in sensitive activities, like example connecting to a database, need to define a static to be worked with JUnit. So basically the idea is that before class will run once before all the test cases, and after class will execute once after all the tests have finished to perform cleanup activities. And ignore is a method which will ignore a test method. This is useful when underlying code has been changed and the test case has not yet been adapted, or if the execution time of this test is too long to be included. So if you want to ignore certain test cases, we can write ignore and it will ignore that test case. So JUnit provides static methods in assert class to test for certain conditions like assert utils. These assertion methods typically start with assert and allow you to specify the error message and the expected and the actual results, which we have already seen. The assert method compares the actual value returned by the test to the expected value and throws an assertion exception if the comparison test fails. So here we have a number of asserts possible. One is fail, let the method fail, might be true, used to check that the certain part of the code is not reached or have a failing test before the test code is implemented. So fail will basically make that case fail. Assert true will be whether the Boolean condition is true. Assert false will test whether the Boolean condition is false. Assert equals, which we have been throwing, test that the two values are the same. For arrays, the reference is checked, not the content of the array. This is important. And for assert equals this particular structure with a tolerance, test that float or double value matches. Tolerance is the number of decimals that must be the same. So we can give tolerance as 0.001 or something like that, and the number of decimals to which the expected and the actual answers need to match. So then we also have assert null, checks the object is null. Assert not null, checks the object is not null. And then assert same, which checks that both variables refer to the same object. And assert not same basically checks whether both variables refer to different objects. So these are the different asserts possible, or the different flavors of asserts possible, in particular using test cases. So here is an example. We have the my class. We have already written some particular package in which we have written x is greater than 999, and we have written some illegal argument where x should be less than 1000. So now if we do return x divided by y, and in this case, this is the Java class, and this is actually the test case. So we have a method which is before class, after class, and we have a test also where we are expecting the illegal argument exception dot class, and then we are basically which is this class, and here we are writing test exception is thrown, which is a method. We create my class object, and then we call the multiply function, and here we are giving two values. So as you can see, as I told you, that in this case fails if the method does not throw the named exception. So if the method does throw the named exception, then this will succeed, else it will fail. So in this case it will succeed because x is more than 999. And then there is another test case which uses assert equals, where we are checking the answer of multiply with respect to 50. And as you can see, this will likely, depending upon the code, of course, here we don't have a multiply code, but whatever is returned, x divided by y, which will be 2. So in this case, again, it will fail because it is not actually going to give you 50. It is going to divide 10 by 5 and it will return a 2 value which is different from 50. So this is an example of how we can create a test case for a Java class, and we can actually run it, and we can actually see the first one succeeded, the second one actually one failed, and the failed because it did not lead to the expected results, 50. So these are the references we use to create this lecture. We request you to please follow these references and learn about JUnit and test cases more. I would like to acknowledge my TAs. It's time for the activity, and in the activity we are going to actually try out the 2 class Java files given in the activity, circle.java and circleconverter.java, which we ran in the last class, and we need to understand what the code does. So remember, it computes radius for an area, and for a radius it can compute an area of a circle. And now we can run this program, and you can also try running it, and then we need to define test cases and by adding a test case file. And this is the kind of test case you need to write. You need to write appropriate code to test the get format area method, get appropriate code to test the compute area method, and get appropriate inputs with appropriate inputs, and write appropriate code to test this format radius and compute radius method with appropriate input. So basically the idea is you need to write 2 test cases, and we need to fill in the blanks in your file. So just to show you, I have tried to solve this question, and this is how it looks like. So we will have to define the circle constructor, and then based on the circle constructor we will define some expected area, and then we will pass it to the assert equal, and then we'll call that compute area, and we will also give a tolerance value. And similarly for the expected formatted area, we will actually format the area up to 2 decimal places, and then we will check it with respect to that. And then for the radius again, we will compute the expected radius with which is 5, and in this case we will give the compute radius with a tolerance, and then expected formatted radius with 2 decimal places. We are again going to compare with this. So this is how you will write these test cases. I would request you to try this out in your JUnit in Eclipse, and we will meet in the next lecture. Thank you so much.